Look at this image of traditional round huts. The architecture relies on heavy materials and a circular base to create a secure, weatherproof structure. Now look at these workers constructing a brick fireplace. Whether you are framing a thatched roof or laying clay bricks, every physical structure relies on the exact same mathematical rules to stack properly and survive physical stress. Outline one of these bricks, and we get a flat, two-dimensional shape formed by straight sides. Any closed shape made with 3 or more straight sides is called a polygon. Recognizing these underlying polygons is exactly how an engineer approaches a massive structure like this cable-stayed bridge. They look at the massive supports and break them down into basic, manageable shapes to calculate stability. Everything we build is an intentional combination of these simple shapes. By understanding how they work, you are learning the foundation of technology and design. This photograph shows the exterior of the National Mosque in Kampala. To secure large architectural features like that massive arch and the towering minaret, builders rely on specific geometric supports hidden inside the framework. That hidden support is usually a triangle, providing the most rigid support in construction. An equilateral triangle has 3 equal sides and identical angles. An isosceles triangle has 2 equal sides. A right-angled triangle contains 1 perfect 90-degree corner. You might assume a square frame is just as stable, since square materials stack easily. But watch what happens. Push a square's corner, and it collapses. Push the triangle, the force distributes evenly. It holds its shape perfectly. Because triangles naturally resist bending under pressure, designers deliberately use them to brace larger, weaker frames. This high-angle photograph of a Kampala city-state shows a different shape dominating the environment. From the buses and vans to the building plots themselves, 4-sided shapes are used to divide space efficiently. Quadrilaterals have 4 sides. Rectangles have 4 90-degree angles. Parallelograms have parallel sides, no 90-degree angles. Trapeziums have 1 parallel pair. A rectangle is defined by 90-degree angles. If we shorten its sides equally, it forms a square. A square is a special rectangle. Understanding these precise geometric definitions ensures accurate measurements when drafting plans or cutting building materials. To draw a circle, start with a fixed center point and create a perfectly continuous curve. Every point on its circumference must be the exact same distance from the center. This distance is the radius. Extending it across creates the diameter, exactly twice the radius. Set your compass point at 0 on a ruler and the pencil point at exactly 5 centimeters. What will the drawn diameter be? It will be 10 centimeters. The compass width sets the radius, making the diameter double that starting width. Now let's apply these rules to a practical task. Suppose you need to draft a metal security gate for a school. The gate needs to fit securely against a wall, support its own heavy weight, and be extremely difficult to climb. Draft a vertical rectangle to align flush against straight brick walls. To prevent sagging, add diagonal crossbars. This creates interlocking triangles that rigidly brace the structure. Finally, to stop intruders from climbing, draft continuous circles along the top edge. This table summarizes your core toolkit: triangles for rigid strength, quadrilaterals like rectangles to align space, and circles for continuous curves or smooth edges. Mastering the exact properties of these simple geometric shapes gives you the ability to draft and construct structures that are strong, reliable, and entirely functional.